And the recording started. Welcome everyone to the Monday, October 2nd, 2023 meeting of SIG Apps. I'm Kenneth Owens. I'll be your host today. My co-host will be Majek. And we only have one topic for discussion today, and that would be declarative node maintenance, KEP 4124. Did anyone want to discuss this?
Yeah, I can take this. Should I present the KEP, or do you want to start discussion, or should I present the KEP first?
Yeah, you can present the KEP and then we can discuss it.
Okay. Can you allow sharing the screen?
Oh, certainly. Sorry about that. Okay, Philip, I'm making you co-host, so you should now be able to present.
Okay, let's see.
And if that stops working, then I will be happy to bring the KEP up for you. For those who want to follow along.
Do you see my screen?
We do.
Okay, cool. In this KEP, like we are looking at the current state of the node maintenance, how we do it today. I will first recapitulate the current state of the node maintenance. So we want to bring the node down for various reasons. Like the kube approach is implemented with kube cattle drain, and the current state is that we run the drain on some node. We first mark the node unschedulable, then we get the pods, then we have a declared list of filters in the kube cattle drain, which filter the pods. We have some kind of pods, for example, the daemon sets or mirror pods that should not be deleted in this stage. So we filter them and then we try the eviction, and the pods should get evicted and we have the node drain. Like the problem with this approach is that this is application agnostic. So we expect that the application should have high availability, and we are also like we are supplying also PDBs to users, so they can use them and decide if they want to step into this process to either delay an eviction of some of the pods, or some users use the PDB as a full stop. So they say they don't want their application to be deleted at all or evicted. And then this brings a problem to the cluster administrator, who then has to decide if these pods, they usually block the eviction. So the administrator has to decide on a pod-to-pod basis what they should do with the pods, if they can delete them safely or not. So to solve this, we are proposing a node maintenance API, which is simple at first, where we can just specify the name of the node and optional reason to tell the cluster on what node we would like to start the maintenance. And so this is useful mainly for the pods that we have, like two sets of pods today. Like we have pods that are not protected by PDBs, and for example they are single replica, and they are not happy about the disruption, but they can live with it. And then we have set of pods that are protected by a PDB, and will not be taken down and will cause a headache to the cluster admin. So this is the proposed solution with the node maintenance. So we will like try to be backwards compatible and use also kubectl drain in this example. So we mark the node as unschedulable as well as in the original, but also we create the non-maintenance object. This non-maintenance object is picked up by the new node maintenance controller, and this will be like the decision point, which pods we would like to get rid of, or like this is like an intent or wish to remove or move these pods out of the node. So like the naive solution is to only select all the pods on the node, but the logic can be tweaked. So we can, for example, make also remove the do not select the pods from the filters of the kubectl, and later we can add like a capability to select some of the pods from these filters. So we can also could say that we want to, for example, remove pods from daemon sets of this priority, and like the critical priority daemon sets would stay, for example, on the node. So the controller works this way, that it selects the set of pods, and then it sets the targeted by maintenance condition on each pod in this node. And then each controller, for example, the deployment controller, would watch its pods, and then it would see that it got a condition that it's targeted by the node maintenance and that there is a request to remove these pods. And like this could be implemented by any controller, and it could be a decision up to the owner of the controller. But for example, in the deployments, we could take a look at the deployment and see that the deployment has a max search, and we would create these search pods on for each targeted pod. And once these search pods become available, we would delete the targeted pods. And also the kubectl drain would gain a new filter here. So if it would detect that it has like a node maintenance support in the cluster, we would filter the search pods, so we would not evict them. So actually, you could say that this solution is like less strong than the original one. So we would not use the eviction, but we would give the application, give them a way to solve the maintenance or like the pod removal request by themselves. And also, another ask of this CAP is to have an observability. So we would show these pods in the status of the non-maintenance, which are targeted to be deleted. So the admin can look at this number if it goes down and see how many pods are still trying to terminate. And also we need an addition to the disruption controller. Yeah, I know there are many components we have to take into account in this CAP, so it's still work in progress. But we could also detect like which like applications or workloads have the max search capability, and also like make them resilient to disruption through eviction requests as well. And we would do this. So for example, we would detect in deployments that we have max search field, and then we would increase the current healthy or desired healthy, so the disruption would not disrupt these pods. And also, like for this, we are using the disruption or the surge detection in pod disruption controller and in the kubectl drain. here where we would also in the beginnings look at the deployment if it has max search field. But later we could add an ability to introduce a search API. So like any workload could implement this API. This is also work in progress. So we would need to detect if, for example, some custom resource has a search ability, and then we could use this to like give the control back to the CRD to do the pod deletion or migration. And also in this example, we are using kubectl drain, but this same process could be implemented by other node drainers. So it would be similar creation of the node maintenance object and then deciding which pods to evict or not. So I can ask.
I have a question about
Yeah.
PDB, right? So you want to introduce this field that kind of like has this notion of a surge. Pod disruption budget is really meant to support kind of the notion of n-1 / n-2 disruption tolerance, right? So like, what's the benefit to doing it this way as opposed to like, if I want to tolerate one disruption and I want to tolerate one unintended disruption, why wouldn't I just increase the scale of the thing that I'm deploying and set the disruption tolerance to effectively be n-2? Or is that not the problem this is trying to solve? Like that's what I understand this is trying to solve, but is that not what you're trying to do here?
Because like, yeah, so sorry, I don't know if I fully got the question, but like the problem I'm trying to solve here is that by like specifying the, for example, the max unavailable, you are first detecting you are first detecting how many pods the application has through to the scale API. So, and then from that you are decreasing the max unavailable. So if you have extra pods above the scale which scale API gives you, these extra pods will like never be covered by the max unavailable because you have extra pods. And these pods can be disrupted. And if you are doing like a migration of data from one pod to another, you don't want this pod to be disrupted in any way, even the extra pods. So we would have to account for that.
I see. So what you're saying is basically you want to temporarily tolerate zero disruptions?
Yes. I don't
think that's going to be feasible, right? Like okay, let's say that the node fails in the middle of that, right? Like you're creating a case that's almost guaranteed to wedge under some constraint.
Yeah, like if the controller behind this fails, it can fail. Like it can wedge. But I mean, like I analyze like some of the use cases people are using today for PDBs. I have like a list of cases above, and like people today are using PDBs that they are actually wedging the eviction. So in this way,
can wedge evictions if you're not careful, but if your goal is to make that better, so like the reason that the API doesn't admit PDBs with a max disruption of 0 is because that's not a sustainable declarative intent, right? If we're going to implement that semantically, my question is more along the lines of, are we really helping, right? Like, is that going to make it easier to use them, or is that just going to make the behavior unpredictable in a different way?
Like one of the things for the unpredictability is that I would like to also have another field in the status, which would tell like the cluster admins, like if the PDB, even if it has max unavailable 0, if it is actually supporting like the drain, or if it has any search pods. And I mean, like
I don't even understand how the surge pods would be computed. Would you have to like watch every node in the cluster, look at every pod on every node where you have potentially one of these newer types of evictions in place, and then try to reconcile the expected number of pods you would want to surge from that with the disruption budget?
Mm,
Like, how do you compute that?
so like the expected search pods are just by detecting like the max search. So in that scenario, it's only like an informational value. Like the important value is that like the current healthy and desired healthy will not allow the disruption. So yeah, sorry, can you say again the question?
How are these computations being done? Like,
so you have like the desired healthy. So this would be like if you have replicas, for example, three replicas, and then you have one search available. So then like desired healthy would be 4, and current healthy could be like depending on like if it is under search or not, 3 or 4. So you would this would like make the pods undisruptable, and the expected search pods would only show that if you want to observe the status and to be to know if you are if your application is healthy or not, you can actually take a look at expected search pods and like subtract this from desired healthy, and then you would be able to see if you have enough pods. If so, this is mainly for the observation if it is behaving correctly. Yeah, I don't know if I should describe, or if you want to know more
but
about this.
I think I get what you were saying. Please continue.
Yeah, so like I was looking at this because like for the PDBs, like people are already like using them like in like this way, which was not like thought of like in the beginning, that people would use this just to block the eviction. And but we have like many cases where people are actually requiring this feature, that they want to be in control of like the disruption of their pods. And we have like cases where people are actually setting this like PDB. They have a controller and they are detecting their own migration, and they are changing the PDB spec according like how many pods are alive. So they are doing this, for example, the search like themselves. So this would like give them ability to just say that you have this search API, we are expected to search, and like we could also like see like we cannot do this before, but we could see this from the search API, and then the like the owner of the component should not have to care about anything else. Just implement search API and implement the migration according the node maintenance like status on the pod or the condition. Any other questions?
Yeah, I have one. Does it mean that we have to update all of our controllers to be able to recognize this new condition on the pods owned by them? Because
Like
that
yeah,
basically assumes that, because if I'm understanding correctly, the goal is to allow the controller react based on whatever each controller is doing. So for a stateful set, it will ensure a proper rollout of a new member somewhere else, and then transition from the old one to the new one. for a deployment, that would be usually just making sure that we can replace one from drain node, assuming that we can fulfill whatever the configuration for a particular deployment was. But that means we would have to upgrade all our internal controllers to respect that condition.
Yeah, and external ones too. If they were-
Right, but I'm if we would consider this as a kube core feature, then as one of the graduation to, or as part of the implementation, we would have to ensure that the default controllers properly handle those. And that would, I would say, at minimum would have to be a requirement for beta graduation when this is actually on by default. But I'm even inclined to say that this could be something that we would require even at alpha stage to ensure that we are working correctly with this functionality.
Like one thing, yeah, like in the long run, I think like it would be the best to have like the most support in like most controllers, even like people outside would implement this. But in the beginning, I think we could just focus on the deployments. And like this is like
deployments are probably the exact thing you don't want to focus on, I would say. Right? Like deployments are usually stateless serving applications that have a relatively simple disruption tolerance scheme. So like that's not a big win. Like the types of applications you talked about servicing, where I indeed believe there are things we could do there to do better, would be more like a storage application that has to sufficiently replicate, let's say, NVMe based SSD to another node in order to maintain durability in the event of a node disruption, in the event of a planned node disruption, right? And then you could do something else maybe to deal with like concurrent planned and unplanned disruptions. I think the thing that we talked about a long time ago, but we haven't really moved forward with, and this is something that is kind of implemented in Borg today, is the ability to coordinate draining with the pod and the application itself. So like the D servers, the disk servers in Google a long time ago, well, I think today they still do this. They have a lifecycle hook that Borg is able to utilize to determine when they're sufficiently replicated in order to terminate them during a drain procedure. So the idea that we should more closely couple the drain procedure with the lifecycle of the application that's being hosted inside the pod and give them some type of hook to communicate their readiness for complete termination, I think that sounds very reasonable to me to do, but it requires some careful thought to do it. When I look at this, it seems like rather than doing that, what we're trying to do is address it very abstractly by touching a very large portion of the API surface. So, and which isn't to say like that's the worst thing in the world, but it just seems to me like if we really want to solve the problem, give the application some way to signal that it's ready, that it's fully ready to be terminated after you've initiated the drain. And that's not an easy thing to do, but if we're going to touch the API surface, I would encourage trying to solve the problem more directly than kind of, well, we'll modify PDB to do this, and then we'll modify all of the workload controllers to do that, right? Like if we can preserve the existing functionality of the API resources and then modify the pod lifecycle to be able to correctly integrate with the drain controller or the node controller, I would prefer that approach.
Like a lot of these things, like which I'm discussing in the CAP, I think are like an extra. Like the main idea here is like we can like postpone the decision on the, for example, the other things, but the main idea is to like communicate the node drain like to the other applications. So this by creation of the node maintenance object. And as you said, like if there are like important applications that are not using, for example, deployments, they could like use this feature right away. Like they can like have their own controller and they can see like this node is draining. We have to move our application. and they don't need to. Then they don't have to even have the PD the disruption controller support. They can like control their own PDB and change it. So I think this would just by introducing the non-maintenance object, this would solve a big hurdle for many people. For example, the other thing I think the non-maintenance controller is also interesting because it gives the intent to the to each pod. So every controller should, if they would only watch the non-maintenance object, they would have to do their own decision on which pods to actually delete or migrate, and this would be a central point of this decision. So it would be controlled in one way, which pods should be migrated or deleted, and this can also give us the ability to control the selection process, which we have, for example, here in the kubectl drain today. So if we would just introduce a non-maintenance object, we would tell all controllers do this selection process by yourselves, and then we would have very disjoint logic across all controllers, which controllers are selecting which pods. The thing you said about the application telling us itself that it is migrating or giving us back the feedback that it is migrating, or if it is ready for migration, if it is migrating correctly. So that could be explored if we can do something like that in different API or in the pod API.
I would specifically in the pod API, we're doing a lot of work here to effectively introduce the concept of draining into the pod lifecycle without actually introducing the concept of draining into the pod lifecycle. My 2 cents. Robbie, your hand's up.
Yeah, I think this is something that we discussed in the past as well. Making sure that the existing API and the controllers play well is something that we need to do. I think having something in the pod lifecycle, which actually talks about health, as well as if there is another entity through which we can set that this particular pod on node N1, it actually can be drained or it cannot be drained. That is something that I would prefer as well. And you can have external controllers managing.
What we capture well, and I think what's called out in this KEP as well, is with the termination grace period, which admittedly does only work inside of Linux containers. But with the termination grace period, we have this concept of, and with health probes, we have a concept of kind of healthy, we have a concept of terminating, but we don't have a concept of, okay, I'm terminating, but please don't kill me because I need to replicate my storage effectively, right?
Yeah.
So again, it seems like that's what a lot of the other modifications to the API surface that are around this proposal are kind of trying to shape. And I would push for, I think we could do something more simple here that's just as meaningful for those things. In terms of the Node API, I mean, that seems fine. It seems like what you're really trying to accomplish is I want a single object that allows a controller to coordinate and drain the node, and then provide some additional utility and automation. That seems because coordinate and drain are outside of unintended disruption, because there are other reasons you would use coordinate and drain independently, but using them in conjunction for maintenance is so common that I don't think it should be very controversial that we want to kind of provide a unified controller that does both of these things. The only other feedback I would have there is it's so you probably still want to use taints. That's probably not you may want to interact with taints. That might not be a either or, right? That might be a yes and. I could think of, for instance, if you have if you're using taints and tolerable, well, I mean, maybe you could do it with just Corden, but I would push you to consider how that interaction might work. And then the other thing that wasn't clear to me about looking at that section is, so is the expectation that at the end of this, the operator, human or otherwise, is going to end up deleting the node and replacing it with another one? Or like, what does the end sequence look like? Like, are you supporting draining Corden for destructive node maintenance or for in-place node maintenance, or both?
Yeah, I think like this is any kind of maintenance, only if you want to do some OS upgrades or if you want to remove the node completely.
So that was yes, both?
Yeah.
Okay.
Yeah, can I ask like what was your opinion on the taints? Because like we have been like looking at the taints like in regard to this like flow, and like the taints like they are not supporting PDBs. So like actually there is there is no way like for people to prevent the disruption by the
Well,
taints.
I mean, I think the interesting portion with taints in particular is with respect to daemon sets, right? So like one of the things from that we thought about with Corden and Drain, and like why daemon sets aren't like as, I don't want to say well supported, but they have a different life cycle with respect to Corden and Drain than the other workload controllers, is that typically daemon sets have things that you need for the node to function. And if you're going to do destructive maintenance, other than things that are like, I mean, even for a storage application, like what you called out is like, if I'm running that as a daemon set on every node and I need to fully replicate all that data to another node, I really don't like care about ever terminating the pod prior to terminating the node itself. I care that the pod has fully replicated the storage that's on it in order to support the durability requirement that I have before I take the node down. So for a lot of use cases with the original design, what we were thinking is you will drain your application pods, but mostly for the daemon pods, they're going to be running like basically node critical administrative tasks anyway. You can think of like the GPU plugin or other resource extension plugins, or the NVIDIA CUDA, NVIDIA GPU operator plugins, or a distributed file system. So like the idea was that for these things, if you wanted to move them off gracefully, then taints would be kind of the thing you would use, right? Like you would taint the node to say, okay, you don't belong here anymore, and get the daemon set controller to kind of pull it off. And when you do that, you could trigger the lifecycle hooks via termination grace period on those nodes in order to do things like force replication. So there are sort of ways that we kind of thought about how the API might have been used to achieve some of the goals you're saying using the existing constructs. But I definitely hear the feedback that like, maybe that didn't work out as well as we thought and we could improve.
Yeah, I mean, like, suppose like if you have like a pod that wants to control their like application lifecycle, then it would have to define like the taint toleration and also the pod disruption budget, because these are two different mechanisms and you can get disrupted in two ways. But like with the taints, like I think like the graceful like shutdown sometimes occurs like when people are shutting down the node, and then there is only a limited time period before the application, like there is a limited window where the application can migrate. So in that scenario, like there are some cases, and I linked also some issues where application doesn't have enough time to migrate, even if they are having the toleration. So
and yes, and there's no indication that they failed to replicate appropriately other than at the application level, right? Which is why I'm saying, like, if you wanted to add draining as some part of the pod lifecycle in order to make that experience better for end users, I think that's fine. And my only question there is, it seems like that's what you're trying to do with a lot of the other API modifications. And my feedback would be, given the scope of work there, it may be easier to do that at the pod level and the pod lifecycle level. But if all the other things are kind of additional thought about how we might in the future like touch the API more broadly in order to support the core feature that you want to deliver, which is the node maintenance primitive, why you might want to scope your KEP a little bit more narrowly, right? To like, I mean, it's good that you kind of started thinking a lot of these things through, but like you said, like some of those things aren't as well flushed out in terms of like outside of the node maintenance API and in terms of the deployment and replica set controllers, pod disruption, and all of that, right? Like if you want to move forward with the node maintenance API, I would suggest flushing that out more and don't focus as much on the other things so we don't kind of rabbit hole. Like I have some concerns about the other things. I think those might be more controversial kind of broadly, right? Because it is a lot of API surface that you're talking about touching. I'm not saying you can't do it. I'm just saying like in the interest of trying to deliver something that's more focused, you might consider starting with really fleshing out the node maintenance spec and the core functionality. And then we can worry about the other things later as those needs evolve.
Yeah, I suppose. Like, yeah, that's a good
Like,
idea.
you have a node maintenance API, right? And you have a spec and a status, and there's a node name and a reason. You do picture having a node maintenance primitive for every node you want to take down. So like if I have a 5,000 node cluster, like you create like some number of these things, like would you not, I mean, typically sometimes we do identify objects directly by name reference, but typically we use like labels and selectors. So, well, I guess you can't do that in this case, but yeah, I mean, like fleshing that out a bit more and thinking about those things and like really nailing kind of how you would initiate node maintenance and coordinate this controller to do, that seems to be something where you could focus. We could get something working, get it like delivered in a reasonable time frame, and then build on top of.
Yeah, I just want to.
I'm not saying don't think about the interactions with the other parts of the systems, but maybe instead of like, I guess like frame it, because the way I read it, it seems like this is all getting delivered as one foul swoop or iteratively. Like, I think it's very good to like think about how this could potentially impact all the other API surface, but I would address that as like potential future work and so forth, as opposed to saying like these are because the way I read it is more like, yeah, we're going to do all of this and we need to do all of this and we think about the ordering of delivering all of this in order to make to get this to even beta, right, or even alpha level, like Majak was saying, and that from a tactical standpoint might be very difficult to do.
Yeah, I agree. Like the scope is very big and like all of the parts are not thought out like in detail yet. So it was just like from the wider scope worked out. Like one note about the node selection. Like we had a small discussion that it might be better to start with like the node name and then we can like add support for some node selector later. So it could be like an optional field. But we could also add the node selector if people think from the beginning it's a good idea.
Well, the one thing, and this is kind of the hard part, right? Like you call out in the bottom of the spec that you think it would be difficult to drive adoption if you don't do this out of tree. If you want to do a lot of experimentation, I would do the experimentation out of tree, because once it goes in tree, like once it goes GA or beta, like you're probably not going to be able to do all of the things, right? So that is kind of the hard part in this ecosystem in general, is how do I design an experiment that I can get adopted out of tree at a scale that gives me good signal that what I'm doing is the right thing. But because you're going to guarantee to get a whole bunch of utilization once we do it in tree, and it's based on our own guarantees to the end user, like it's not a very mutable thing, right? Like the only way once it goes GA that you can fix anything you've done is to go to GA2, right? Which very few APIs have done. You've got like horizontal pod, autoscaler. There are very few APIs that have actually gone that route. So I'm not opposed to like, I think you should take it to API machinery and get their feedback on that too. I am not opposed to like saying this is something that we have enough data on based on the current utilization of cordon and drain in the node eviction process where we think we could add value on it. But your choices are going to be really like you get this API fairly good on the first time around and do it in tree, or you can be very much more experimental and iterative and deliver something and play with it and like let the community play with it and then bring it into tree when you've got a very robust solution. So like you kind of can't have it both ways, right? Like either you have the confidence that the API you've got is the right thing and we're going to promote this to alpha, get some, because no one's going to use it at alpha either, right? Like by default, all the alpha flags are off at this point, and unless you've got a particular like need that you're addressing for a cloud provider where they're telling you they're going to turn on the alpha flag on their distribution or some other Kubernetes distribution, it's not going to get used till it goes beta. And once it goes beta, I think we're even not doing beta anymore. We're going to have to go GA. You're not like you're going to have to go fairly well live with it before you actually get utilization. So if you don't think that you can get it right on the first go round, it's going to be not happy fun times. Like you should probably do it out of tree and iterate on it until you like, I'm very confident that this is the right thing to do for this API.
Yeah, I agree. Like in some way that if we like have a complex API, that it would be very hard like to backtrack. And
no, there is no backtracking. Like once it goes GA and once you actually get the signal you're looking for by having people use it, we treat it as a dependency, and the only way to deprecate it is by releasing a V2 of the API, right? So it's very long lived for many years that we will be supporting this as a community, right? So like you gotta like if we want to do it in tree, we gotta make sure that we get it right.
Yeah, I had in mind in like a beta and then after GA, yeah, that's bad. So like since like the users of this feature are like they are usually trying to achieve like some data resiliency or something, so it's like quite hard to get the adoption because like they need to be they need to be sure that it's like this like functionality is under every cluster they are deploying to. So I think we can like be sure that we have the correct API if we really start very small and just, for example, have the non-maintenance object with the name or the selector, and then like have like once we are sure about the other requirements, we can increase the capability of the non-maintenance MPI in the future, like with another feature guest and another like Kubernetes graduation process. So we could like remove the deployment and search and everything and just have the node maintenance and marking the pods. Like we could discuss like the pod API in more detail, like what we want to have it and what to signal like from to the pod and out of the pod. And if we have this correctly, we can then build on top of that.
Makes sense. Just and make sure if we're going to propose doing it in tree that the minimal subset of the API that we want to. So you can always kind of add to an API, right? Like that's considered backward compatible. It's things like if you have node name in there, like and it's GA, removing it's extremely problematic because it's a backward incompatible modification. And then semantics too, right? Like we consider semantic changes to the underlying behavior of the controller to be binding. So if it GAs and it behaves in a particular way, you can't just like arbitrarily modify the behavior without adding some type of a switch to give it some additional functionality. So just, be mindful of that as it evolves. But yeah, your course forward sounds reasonable to me, at least for what my 2 cents is worth.
Okay, cool. So I will like try to rewrite the cap and explore the pod API more, and then I can, for example, bring this to API machinery and ask what they think. Like, does anybody have other questions?
I'll take that as no. So thank you, Philip, for your presentation and your contribution thus far. And let us know how we can help you continuing to shape it and contribute it. Does anyone have any other topics they would like to bring up today? Okay, I'll take silence for a nothing else to talk about today. All right, thanks everyone for their contribution in terms of attendance and having a lively conversation. We'll see you during the next SIG Apps meeting, and have a good week and a good day.
Thank you.
Thank you. Bye.